Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I'm your host, the Dabbling Doggo.
I dabble.
Last week, we were introduced to the world of analysis and visualization using the Julia programming language. We installed VS Code, and then added some packages to enhance our experience. Then, we performed a quick analysis of the iris flower dataset and generated a vector graphic plot to use in a presentation. Today, we'll start by stepping back to get an overview of analysis. After that, we'll sharpen our analytic skills by using some real-world business applications. Along the way, we'll continue to add to our visualization toolkit by learning how to use Cairo Maki, which is the premium backend to the Maki plotting package. This past week, my little YouTube channel reached 100 subscribers. I want to take a moment to thank all of my subscribers. Your support means so much to me, and it keeps me motivated to continue creating new tutorials for you. In order to commemorate this milestone, I set up a GitHub repository, which I'll link in the description below. I put all of my files from the first tutorial series there, and I will add files for this second tutorial series on Sundays as I post new tutorial videos. Thanks again to all of my subscribers. And now, back to the show. The English word analysis comes from the ancient Greek word meaning a breaking up. The origin of the word is very appropriate. Wikipedia defines analysis as the process of breaking a complex topic or substance into smaller parts in order to gain a better understanding of it. The history of analysis as a human activity goes back to ancient times, while the modern, formal concept of analysis has been ascribed to Alhazen, Descartes, Galileo, and Newton. While the history of analysis is rooted in math and science, in practice, analysis is used in many different fields, ranging from music and literature to philosophy and psychotherapy. It's used in the public sector to set public policy and to acquire security intelligence. It's used in the private sector to bring a more disciplined approach to business and economics. While analysis is often associated with math and science, it's important to understand that analysis is a general process that is independent of domain. With respect, lawyers are not known for their math and science skills, and yet, lawyers often turn out to be excellent analysts because their profession requires the use of logical thinking to dispassionately examine the evidence in order to formulate an argument or an opinion. The objective of their process is not about finding the correct answers to a problem set. Their objective is to convince a judge or jury to a particular point of view based upon the evidence presented. This process is similar to the one used by analysts. While the use of computers may allow the analyst to tackle more complex cases, it's important to understand that at its core, analysis is an ancient human activity that we've been using for thousands of years to help us understand the world around us. Let's take a break from the ivory tower and take a look at a couple of real-world examples of how analysis is used in the business world. In the first example, we'll take a look at the classic microeconomic model of supply and demand in order to gain a better understanding of the market behaviors of companies and consumers. In the second example, we'll create a mortgage calculator in order to better understand how fixed-rate loans work in the US. Boring! I know that sounds really boring, but I promise that it will be fascinating. According to Wikipedia, in microeconomics, supply and demand is an economic model of price determination in a market. It postulates that, in a competitive market, the unit price for a particular good will vary until it settles at a point where the quantity demanded will equal the quantity supplied, resulting in an economic equilibrium for price and quantity transacted. Did any of that make sense to you? It might be easier to see on a diagram. In microeconomics, the standard graphical representation of supply and demand is plotted on a chart showing the relationship between price and quantity, with price on the vertical axis and quantity on the horizontal axis. Consumer behavior is represented by a demand curve. At a high price, the quantity demanded is low, since the perception of consumers is that they're getting ripped off at the high price. At a low price, the quantity demanded is high, since the consumer perception is that they're getting a great deal at a low price. So, without knowing anything about economics, common sense would tell you that the demand curve is a downward sloping curve on this diagram. On the flip side, company behavior is represented by a supply curve. At a low price, the quantity that the company is willing to supply is low, since the company doesn't have enough of a profit incentive to sell their product at a low price. At a high price, the quantity that the company is willing to supply is high, since the company now has a large profit incentive to sell as much product as possible at that high price. Again, without knowing anything about economics, common sense would tell you that the supply curve is an upward sloping curve on this diagram. The intersection of these two curves is what economists refer to as the economic equilibrium price and quantity. In theory, at this price, the company will sell all of their products and will not have any excess inventory, nor will they have any back orders. Let's use the examples provided in the Wikipedia article to see if we can use Julia to determine the equilibrium price and quantity. Open VS Code. Create a new file by going to File, New File. Save the file as tutorial02x02.jl by going to File, Save As. Remember that you can find the .jl file extension by scrolling all the way down to the bottom. Make sure that your plots panel is showing by going to View, Command Palette, and then selecting Julia Show Plot. Click in the terminal and hit Alt-J, then Alt-O to start the REPL. One last step. Go to File, Preferences, Settings. Go to Extensions, Julia. Look for Julia Execution Result Type. Change the option to Both. Repeat this step in the Workspace tab. Close the Settings tab. Okay, let's start coding. As always, typing in the comments is optional. In the Wikipedia example, the formula for the supply curve is Q of P is equal to 3P minus 6, where Q is quantity and P is price. Select the row and hit Shift-Enter. VS Code displays the response next to the cursor, so if you want the response to display next to your code, then be sure that the cursor is at the end of the row when you hit Shift-Enter. In case you haven't watched the first video in this tutorial series, I changed the default key bindings in VS Code so that Shift-Enter will execute a block of code. Let's plug in the value of $5 for the price to see the resulting quantity. Select both rows and hit Shift-Enter. Select both rows again, but this time hit Ctrl-C to copy. Go to the next row and hit Ctrl-V to paste. Change the 5 to a 10. Select both rows and hit Shift-Enter. So, just based on these two price points, you can see that as the price increases, the quantity increases as well. This confirms our intuition that the supply curve is an upward sloping curve. Now let's do the same thing for the demand curve. In the Wikipedia example, the formula for the demand curve is Q of P is equal to 32 minus 2P. Select the row and hit Shift-Enter. Go back up to P equals 5 and then select the 4 rows of code and then hit Ctrl-C to copy. Go to a row below the demand curve formula and then hit Ctrl-V to paste. Select the first 2 rows and then hit Shift-Enter. Select the next 2 rows and then hit Shift-Enter. So, just based on these 2 price points, you can see that as the price increases, the quantity decreases. This also confirms our intuition that the demand curve is a downward sloping curve. We can continue plugging in numbers, but it would be more helpful if we could see the supply and demand curves on a plot. Let's use Chiromakey to generate these plots. Go to the REPL and maximize it by clicking on the up arrow. Enter the close bracket to enter the package REPL. For some reason, when adding packages, Julia sometimes adds an older version. Adding the add character after the package name will ensure that Julia adds the correct version for that package. When completed, enter status to confirm the version information. Double-check that you've installed Makey version 0.12.0 and Chiromakey version 0.3.12. hit backspace to exit the package REPL. Minimize the REPL by clicking on the down arrow. Go back to the editor. Maki is a plotting package created by Simone Danisch. Most of the other plotting packages available in Julia were originally written in other programming languages, so they are not necessarily optimized for Julia. Maki was written from the ground up using Julia. It has some amazing capabilities, but it's still very new, so it's evolving rapidly. Admittedly, it's not the easiest plotting package to learn, but it has tremendous potential, so it's a good one to have available in your analysis toolkit. Maki Layout was a companion package to Maki that was created by Julius Krumbiegel. I apologize for my pronunciation. Initially, it was a separate package that added some powerful layout features to Maki, but it has since been integrated into Maki. This integration just happened recently, so the version of Maki that we will be using is actually different than the one I was using during my first tutorial series just a few months ago. Plotting packages have a front end and a back end. The front end is the part that the user interacts with in order to enter the plot specifications. The back end is how the specifications are displayed on your monitor. It's possible for a plotting package to have multiple backends. During my first tutorial series, we used the default backend to Maki called GL-Maki, which I never even mentioned in my tutorials because it's used by Maki by default. In this tutorial series, we'll be using another Maki backend called Kairo-Maki. Kairo-Maki is a Maki backend that is capable of generating publication quality vector graphics. The name Maki comes from the Japanese lacquer decoration technique. I won't attempt the Japanese pronunciation, but here are a couple examples from the internet.
Makie.
Makie.
In the US, we would pronounce this as Makie. However, Simone Danisch pronounces it Maki, so I'll go with his pronunciation since it's his package. Now, back to our example. For both the supply curve and the demand curve, economists define quantity as a function of price, meaning that price is the independent variable while quantity is the dependent variable. In math, the convention would be to plot price on the x-axis and quantity on the y-axis, since the independent variable is typically plotted on the x-axis in math. However, in microeconomics, the axes are switched due to historic conventions, which can be confusing if you're not aware of the historic context. When plotting functions, Maki follows the math convention, so it's expecting the independent variable to be plotted on the x-axis, so that it can return the dependent variable to plot along the y-axis. That means that we need to reconfigure the supply and demand functions to follow the math convention and not the microeconomics convention. In order to have quantity plot on the x-axis and price plot on the y-axis, we need to express price as a function of quantity and not the other way around. Doing some simple math, the supply curve would look like this. And the demand curve would look like this. Select the rows from P supply to P demand and hit Shift-Enter. Now we're ready to generate a plot. Select the row and hit Shift-Enter. Select the two rows and hit Shift-Enter. You should see a blank white plot show up in your Plots panel. You may have to adjust the resolution dimensions to match your screen resolution. On my monitor, the empty plot sits nicely in my Plots panel. The scene variable is the name of the overall plot that we are generating. As its name suggests, the layout variable contains the plot layout elements that sit on top of the scene layer. I know that this may be a little confusing at this point, but it should become clearer as we continue going through this example. Select all rows and hit Shift-Enter. You should now see a blank layout showing a title and some labels. I know that this code may seem a bit verbose, but everything you see here is customizable to fit your needs. For the Y-tick format, that syntax may be unfamiliar, since it is not standard Julia syntax. The curly braces, with a :D inside it, indicates that the number on the y-axis should be displayed as integers. Now, let's select the range for the x-axis. Select the row and hit Shift-Enter. This states that we want to plot the independent variable q from 1 to 25. Select the two rows and hit Shift-Enter. You should now see the supply curve on the plot as an upward sloping blue line. Notice when calling the lines bang function, we are plotting onto the axis, which sits on the scene. So there are three layers now: a scene, a layout, and now a plot. The intermediate layout layer is what allows us to customize the titles and labels easily without disturbing the actual plot. Select the two rows and hit Shift-Enter. You should now see the demand curve on the plot as a downward sloping red line. Let's add a legend to our plot. Select all of the rows and hit Shift-Enter. Adding a legend is surprisingly verbose. That's because creating a legend is like generating a mini plot on top of another plot. All of those attributes can be customized to fit your needs. Rather than me going through all of the attributes to explain them, it's best for you to play around with the settings to see what changes, so that you can choose the settings that you like. You can copy the code from my source code file in my GitHub repository. Although there's a lot of code here, the good news is that once you find the settings that you like, you can simply copy and paste this code to any future plot. Now that we have a supply and demand plot, we need to find the equilibrium price and quantity, which is at the intersection of the supply and demand curves. Just by looking at the plot, it looks like the equilibrium price is around $7 or $8, and the equilibrium quantity is around 17 units. If we want to find the exact coordinates, then we need to use linear algebra. However, before we can use linear algebra, we need to reconfigure the supply and demand curves again to match the AX equals B format, where A is the matrix of the constants attached to the variables, X is the vector of the variables, and B is the vector of the constants without the variables. Now that we have our formula reconfigured, we can load the matrix A and the vector B into Julia. Select both rows and hit Shift-Enter. In order to solve for the vector x, we need to use the formula A\B. Select all of the rows and hit Shift-Enter. It looks like we were close just by looking at the plot. The equilibrium price is $7.60, which is in between the $7 or $8 that we guessed. The equilibrium quantity is 16.8 units, which is close to the 17 units that we guessed. Let's add the equilibrium pricing quantity to our plot. Select all of the rows and then hit Shift-Enter. The v-lines bang and the h-lines bang functions generate either a vertical line or a horizontal line respectively. The location of those lines need to be entered as a single element array. The xmax and ymax attributes are also entered as a single element array, but must be a floating point number between 0 and 1. The number indicates how far you want that line to travel away from the axis relative to the size of the plot. For example, if you entered 0.5, the line would go halfway from the axis. I'm not sure if there's a more precise way to calculate this number, but I had to find my numbers using trial and error. Let's save our plots and then insert it into a word processing app. Select the row and hit Shift-Enter. Do a web search for random text generator. Go to the Lipsum generator website and click on the Generate Lorem Ipsum. Select the random text and copy it. Open up your word processing app. I'm using Microsoft Word, but you can use any app. Create a new blank document. Paste your random text. Merge formatting. Click after the first paragraph and hit Enter. Insert your SVG file. Select View Whole Page. Resize your image so that the width is about half the page width. In the Layout options, select Square. Select Align Right. Save the file as Econ Paper. And now, not only do you have a better understanding of the market behavior of consumers and companies, you also have a very professional looking paper that proves it. Before we go to the next section, click on the REPL and hit Ctrl-D to exit the REPL. Our next example is a mortgage calculator. This example will work for any fixed-rate loan in the US, like a car loan or a student loan, and not just home mortgages. If you do a Google search for loan calculator, it brings up their own mortgage calculator that calculates the monthly payment based on the mortgage amount, the interest rate, and the mortgage period. It also provides a total cost of the mortgage. Google doesn't provide any backup to this calculation, so let's see if we can recreate the results using Julia. In VS Code, click on the terminal and hit Alt-J, then Alt-O to restart the REPL. Click in the editor to begin entering code. Skip a few rows before typing in the next section. Before we can write any code, we need to find a formula to use. Thankfully, there's a Wikipedia article called Mortgage Calculator that provides a couple of monthly payment formulae that we can use to calculate the monthly payment for a fixed-rate mortgage given the values of the variables R, N, and P. R is the monthly interest rate. In the US, banks advertise their lending rates as an annual percentage rate, or APR. The monthly interest rate for a fixed-rate mortgage is just the APR divided by 12 months. N is the number of monthly payments. In the US, banks advertise the length of their loans in years. The number of monthly payments is just the number of years times 12 months. P is the amount borrowed, which is also known as the loan's principal. There are two formulae that we can use to calculate the monthly payment amount. I'm going to use the formula on the left, since it's a little easier to type in. However, you can use either formula, and it will give you the same answer. Select the rows and hit Shift-Enter. Next, we need to initialize the variables with the default values from Google's mortgage calculator. Select all the rows and hit Shift-Enter. Now, let's try out our new formula to see if we can get the same payment information as the information provided by the Google Mortgage Calculator. Select the row and then hit Shift-Enter. Now, let's calculate the total cost of the mortgage. Select the row and hit Shift-Enter. Great! We got the same answers as the Google Mortgage Calculator, so we know that the formula that we found in the Wikipedia article works. Having a mortgage calculator is nice, but it's a black box, since all we're doing is plugging in variables into a function and having the function spit out the answer without any explanations. For example, the total cost of the mortgage is $170,000, which means we would have to pay $70,000 in interest payments. How did an interest rate of 3.92% on $100,000 turn into $70,000? In order to better understand how this loan works, it would be helpful to have a table that shows the effects of the monthly interest charge and the effects of the monthly payments on our opening and closing balances for each month for the length of the loan. How could we generate such a table? Before writing the code to generate this table, we need to understand a few concepts. The first concept is something called base, which stands for begin, add, subtract, and end. I'm not sure if they teach this at school, but it's used in business all the time. For example, base is used to keep track of inventory. Let's say you're running a business that makes and sells widgets. If you start with a beginning inventory of 0, and you add a production quantity of 25 widgets, and you subtract a sales quantity of 10 widgets, then, by using base, your ending inventory is 0 plus 25 minus 10, which equals 15 widgets. The ending inventory for this month then becomes the beginning inventory for the next month. You repeat this process every month to keep track of your monthly inventory balances. We can use this concept to help us generate a mortgage table. The beginning balance will be the initial amount of our loan. Next, we add the monthly interest charge. Then, we subtract our monthly payment. The result is the ending balance for the first month. The ending balance for the month becomes the beginning balance for the next month. We repeat this process for the number of months for this loan. The second concept to know is that Julia stores the data in any array as a column vector. So, if you use a for loop to push a bunch of data into an array, the resulting array will be a column vector. The third concept to know is that in Julia, multi-dimensional arrays are displayed in column major order. So, if you reshape a column vector into a two-dimensional matrix, Julia will initially populate all the rows in the first column before moving to populate all the rows in the second column, and so on. Armed with this knowledge, let's try to create a function that will generate a mortgage table for us so that we can better understand how fixed-rate loans work. At the same time, let's change how we enter in arguments to our new function so that it's more consumer-friendly and matches how the Google Mortgage Calculator works. Select all of the rows and hit Shift-Enter. I know that's a lot of code, so I don't expect you to type all this in while you're watching this video. You can find this code on my GitHub repository so you can examine it when you have some time. Despite the length of the code, it's really just repeating base multiple times. It's calculating the beginning balance, and then adding the interest charge, then subtracting the monthly payment amount to arrive at the ending balance. After generating the data, which is stored as a column vector, the code simply reshapes the vector into a more human-readable matrix. Let's try it out by using the default values from the Google Mortgage Calculator. Select all of the rows and hit Shift-Enter. Well, it generated an array with 360 rows and 4 columns, which looks promising. Let's take a look at the matrix by using VS Code Display. Select the row and hit Shift-Enter. Column 1 is the beginning balance for each month. Column 2 is the interest that the bank charges you every month. Column 3 is the payment that you make to the bank every month. Column 4 is the ending balance for each month. As you can see, the beginning balance for month 1 starts at $100,000. If you scroll all the way down to the bottom, you'll see that the ending balance for the last month is 0. These are floating point numbers, so you'll see a very small number at the end that is essentially 0. In reality, the bank will round off your payment number to the nearest penny, so the actual table that your bank uses will be slightly different. The other thing that you'll see is that all the numbers in column 3 are the same. That's because that's the amount that you owe to the bank every month for the next 30 years. Depressing, right? Finally, in column 2, we see that the amount is decreasing over time. It starts at around $327, but ends up around $50. That's because the interest that the bank charges you is based on the beginning balance for that month. As your beginning balance shrinks over time, so does your monthly interest charge. You can save your matrix as a CSV file. Select the rows and hit Shift-Enter. Delimited Files is part of Julia's standard library, so there's no need to add it. You can view your CSV file by clicking on the Explorer icon in VS Code. Clicking on your CSV file will open it as a new tab. You can use the mini-map to scroll through your files. Open up your Spreadsheet app and open your CSV file. I'm using Microsoft Excel, but you can use any spreadsheet app. Be sure to change the file type to All Files so you can see the CSV file extensions. Format the columns to show $signs and make the column widths equal. Save the file as pmt_table.xlsx. Close the Spreadsheet app. In VS Code, close Explorer. Close the CSV tab. Close VS Code Display. The table views are interesting, but it would be helpful to have some plots so that we can better understand the data. Before we can generate plots, we need to prep the data. Select the rows and hit Shift-Enter. Our mortgage table shows our total monthly payments and the monthly interest charges, but it doesn't show how much of the monthly payment is going towards paying down the principal, which is just the total monthly payment minus the monthly interest charge. Now, let's generate some plots using Karyoramaki. Select the rows and hit Shift-Enter. Note that the resolution is different. This time, we're going to generate two different plots and then put them side by side. Go up to the code with the supply and demand plot and copy the code under the At Axis section and paste it here. Change At Axis to At First Axis. Change AX to AX1. Change Quantity to Months. Change Price to dollars. Change Supply and Demand to Monthly Payments. Select all rows and hit Shift-Enter. Select all rows and hit Shift-Enter. You should now see a very wide plot. Don't worry, when we add the second plot, it will automatically reformat itself. Let's add a legend by going back up to the supply and demand plot and copying and pasting the legend code. Change LEG to LEG1. Add line object 3. Change supply demand to principal, interest, total payment. Change v-align from top to center. Change label size from 7 to 5. Change patch size from 2010 to 15.5. Change layout11 equals LEG to layout11 equals LEG1. Select all of the rows and hit Shift-Enter. Scroll right to see the entire plot in the plot panel. For our second plot, let's take a look at how much we're paying on principal and interest over time. We have the data on how much we're paying each month, but we need to calculate a running total and put those amounts into a vector. Select all of the rows and hit Shift-Enter. Select both rows and hit Shift-Enter. This is the cumulative principal payments. It starts at $146 and ends at $100,000. Close the Julia Table tab. Now, let's calculate the cumulative interest payments. Select all rows and hit Shift-Enter. Select both rows and hit Shift-Enter. This is the cumulative interest payments. It starts at $327 and ends at $70,000. So, the bank gives you $100,000, and you have to give them $170,000. Does that sound like a good deal to you? For better or for worse, this is how a lot of folks in the US live, buried in debt. Close the Julia Table tab. Let's plot this data to see if we can gain a better understanding of how these payments look over time. Copy the axis information from the first plot. Change AX1 to AX2. Change layout 1.1 to layout 1.2. Delete Y-label equals $. Delete Y-label size equals 10. Change Y-tick label size equals 9 to Y-tick label size equals 7. Change monthly payments to cumulative payments. Select all rows and hit Shift-Enter. Now, you should see that the plot has reformatted to fit two plots side by side. Let's add some line plots to the right side. Select all rows and hit Shift-Enter. Scroll to the right to confirm that the second plot has been added. Go up to Legend 1 and copy and paste the code. Change LEG1 to LEG2. Delete line object 3. Delete total payment. Change H-align right to H-align center. Change V-align center to V-align top. Change layout11 equals LEG1 to layout12 equals LEG2. Select all rows and hit Shift-Enter. Scroll to the right to confirm that the second legend has been added. Save the plot as mortgagecalculator.svg. Select the row and hit Shift-Enter. Open up your SVG file in your browser and zoom in to fill your screen. If you look at the plot on the left, it shows that of the initial monthly payment, roughly 2/3 is going to pay interest, while only 1/3 is going to pay off the principal. In fact, for roughly the first 10 years, you're mostly just paying interest. The plot on the right shows how those interest payments add up over the years. 3.92% may sound like a low number, but as you can see, it adds up over time. Go back to the Random Text Generator website and copy the text. Open up your word processing app again. Create a new blank document. Paste your random text. Merge formatting. Click after the first paragraph and hit Enter. Insert your SVG file. In the layout options, select Top and Bottom. Save the file as Mortgage Calculator. Go back to VS Code. Save your file by going to File, Save, or just hit Ctrl-S to save. Okay, so maybe that wasn't as fascinating as I had promised, but these examples did demonstrate some important aspects to consider when using Julia as an analytic tool. First, you need to spend some time in order to prepare your information so that Julia can understand it. Just because you have the formula for supply and demand, that doesn't mean that Julia will understand how to plot it or how to solve linear algebra equations with it. Second, when dealing with data in Julia, it's important to think in terms of column vectors. Regardless of the shape of the array, at its core, Julia views all of your data as one tall column vector. In our mortgage table example, our nice 360 by 4 matrix started its life as a 1,440 element column vector. Third, visualization is not the end product of your analysis. Visualization is a part of the entire process, whether it's at the beginning, middle, or end of your analysis workflow. Different plotting packages offer different strengths and weaknesses. Last week, we used Data Voyager. Its intuitive drag-and-drop user interface makes it an excellent tool for the early exploratory phase of your analysis. However, its customization capabilities are limited, so it's not necessarily the best visualization tool moving forward in your workflow. Today, we saw the other end of the visualization spectrum. Maki is a massive plotting package that is endlessly customizable. However, being able to harness its full potential requires some investment on your part to learn the more verbose syntax. While it may not be ideal for early-stage exploratory analysis, it's an excellent tool for the mid to later stages of your analysis workflow. Finally, regardless of which tool or tools you choose to employ, they are no substitute for your own mind. At the end of the day, the real analysis is performed by you and not your computer. The most important skill that you can learn over the next several weeks is to learn how to harness that ancient power that we humans developed in prehistoric times to separate ourselves from other animals. That being the human instinct, to take things apart and to wonder how they work. Well, that's all, folks. From today's demonstrations, I hope that you can see that Julia can be a powerful addition to your analysis toolkit. We looked at a couple of real-world examples of how you might be able to use Julia to help provide insights in a business context. We were also introduced to Kairomaki, which offers very sophisticated plotting options in order to assist you through your analysis workflow. I know that there was a lot of code in today's video, so please check out the source code in my GitHub repository. The link is in the description below. Next week, we'll cover the very exciting subject of optimization using Julia. If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more wholesome Julia tutorials, please be sure to subscribe and hit that bell. New tutorials are posted on Sundays. If you have any questions, please post them in the comments below. Please feel free to share these videos since these tutorials are getting rave reviews. Just listen to what the professional reviewers are saying.
You should be ashamed of yourself. Your family should be ashamed of you. They should. They should.